Evaluation for your generative AI applications. This was a recent talk I did for ODSC. Wanted to make a version for the rest of you. Now, 3 big things I want you to take away. One is GenAI is a little bit different in terms of the technical nuances that's important to know if you're building applications. Second, I wanted to give everybody a basic intro workflow for how you can build an evaluation dataset, how you can do evaluation with generative AI. And finally, I'm hoping I can inspire all of you to go out and actually start doing evaluation, because in the world, that's how you actually learn this stuff, is by doing, not reading papers or watching videos like that. Now, in the beginning, I always like to kind of motivate these talks with a funny anecdote. And the idea here is one of the biggest use cases for GenAI is helping to write those customer support tickets, emails out there. Anybody can go grab a little bit of a prompt, do a little vibe coding, have a model write out a GenAI output. So you can get a customized response like this. This stuff works really good out of the box. And you're probably thinking, hey, I'm done. If you're building that quick demo app, you're good. But if you're in this game long enough, you'll see that, wait a minute, these things don't always work, right? Like I asked about an order delay, but my email tells me about a new product line, right? It doesn't match at all. Or somebody asks about a specific order, and we tell them that they're sorry that their espresso machine arrived defective. Well, wait a minute, we don't actually sell espresso machines. There was an hallucination here that happened. And this is not isolated incidents. Cursor, the folks that build you that wonderful IDE, well, they were using a customer support bot, and guess what? It created a policy that said you're only allowed 1 device per subscription. And the reality was that wasn't right at all. You could use multiple ones. And this led people to mistake Cursor's policy and actually cancel their subscriptions like that. Besides that, GenAI has always been problematic around the inputs and outputs and whether there are copyright issues. We also know if you're using these GenAI bots and having them out there, that courts might be held that it's no different than an employee. If your GenAI bot does something or creates a promise, well, you got to back that just like if your employee did that. So there is a huge set of mistakes that you have to be worried about, which should cause you pause as somebody that's going in and building these systems. Now, what's happened and what's different in 2025 is it's not just you that's thinking about this, it's the executives, because they've seen the numbers. They've seen how many GenAI projects that they've invested into that haven't had huge returns. The 95% is way overstated, but still, GenAI can be useful, can have some good results, but it's not always a sure thing that it's going to be massive like that. So, where evaluation comes in is it helps you build better GenAI applications. I've been in this space for a long time. About 2 years ago, I did this video, been widely seen around doing evaluation. It's still a good video, a lot of good points here, but this is a little bit more condensed version of that video with a little fresher content for all of you all like that. And I always like to start with why evaluation is important. It's important if you're for yourself to build a better application, to understand what's working and what isn't. But then you need to also convince your team, your managers. So you need to be able to show them hey, I ran this data set on things that hadn't seen before, and look, it's holding up okay. As well as maybe you need to go convince regulators or a third-party model evaluation team. Well, you're going to have eval data sets. You're going to have methodologies that you need to be able to show them that your app is going to do what you want it to, and you have confidence and trust that it's going to perform in this. And evaluation covers a lot of stuff. I know as data scientists, we end up often talking about this technical piece. One thing I like to stress is you also have to think about the value of your applications. What's the ROI that's going to do it? At the same time, keep in mind the operational costs as well. What is the cost of ownership? This is one of the issues with, for example, GPUs and enterprises, where it costs a lot to have a locally hosted open source model that you're running 24/7 inside an enterprise, which is often why people go to APIs. But these types of considerations of what is it going to cost to actually run your solution on a day-to-day is an important thing that you need to think about at the outset of your application. Now, I think at this point, we're all mature enough when we realize that companies out there promote their LLMs with these public benchmarks. We know these public benchmarks, they're great for like giving you a rough performance of the LLMs, but you're not going to use them to figure out, is this a good fit for your application? Instead, you want to build benchmarks, data sets that reflect your case like that. So let's jump in. Let me help you kind of tame generative AI. Now, we're going to start with the basics of how generative AI works. We're going to build an evaluation workflow and then add more complexity. And finally, we'll get to the more agentic stuff. When I gave this talk at ODSC, we ended up with so many questions. That's the advantage of you catch me in person, that we didn't get to the later parts. I get to cover the later parts here in the video since none of you can. I'm not going to stop for any of your questions right now. So the reason why GenAI is so hard is if you write a prompt like this, you're going to go through and you're going to get an output. But here's the same thing. If you just wait a minute or two, your system's going to give you a different output. Now, in this case, the outputs are substantively the same, right? They're covering the same types of materials around investigations and help. But you see there are slight differences. And when we get to evaluation, this becomes an important consideration for us. And I want to break this up because there's a lot of places where this happens. And we're going to just systematically go through it. We'll talk about inputs, the model, and then output. So the first thing is we see some inconsistent scores around benchmarks. And this is a story I told many times. I still like to tell it. I worked at Hugging Face. Tom Wolfe, one of the co-founders, loves to talk about new great open source models. Tweet it out, let everybody know, look how good it is. Look at the performance that we see across all of these benchmarks. Well, in this case, when he tweeted it out, somebody else tweeted back, wait a minute. How come the numbers you're tweeting out differ from the ones that are actually in the Llama paper? Now, in both of these cases, you're using the same data set, as we'll talk about MMLU, but why are we showing two different numbers? Now, MMLU is a multiple choice benchmark. It covers like history, economics, biology, like questions that like high schoolish kind of collegish questions around knowledge in these areas. So it's often used to measure like how kind of smart a model is, like that. But why would two different models get different scores on a multiple choice test? Like, it doesn't make any sense if you think about it. Well, it turns out if we dig into it that if we look at the three evaluation harnesses that were used, three different approaches, they each wrote their prompts slightly different. If you take a look here, you'll see that there's slight differences in the prompt where one of the how they phrased it, some use the word question, you see the word choices here. All of this ends up affecting the overall accuracy of how we evaluate the model because it leads to changes in the output. And look, this isn't crazy stuff. Like Anthropic wrote about this too, how just changing the options from parentheses A to parentheses 1 or going from round parentheses to square parentheses had an effect on the output. Now, this hasn't changed recently. If we look at, for example, GPT-4o, still very sensitive to the prompts that are there. And we've seen this in a number of recent studies where how you change just the tone of what you're doing can affect the overall accuracy. So how you ask something can do that, right? Like, I guess this is why mom always had to be polite, right? And it's still a huge piece. You still see posts like this that tell you, hey, use specific phrases, do this, because these models still, even years later, are still kind of sensitive like that. Hopefully, 2 years from now, this won't be an issue, but for now, it is. So a second story I like to tell, and this is about the Falcon LLM model, is when it was first released, people were trying out different things. And part of it is, right, it came out from the Middle East and some people were concerned, like, hey, wait a minute, like, could this be biased in some ways? And they tried different queries. And one of them said, recommend me a technological city. And why did it recommend Abu Dhabi? Like, did they train it themselves? Did they change the input data into this? Did they alter the weights or something? People were a little confused, and there was even concerns like maybe this is covering up human rights issues because it gives different answers for different cities like that. Well, someone on the team kind of dug into this. And like anything, when you start digging into this, do you jump right into like looking at model weights or anything? No. You look at what's the inputs into the model. Well, besides your query, a system prompt. And it turns out that the system prompt here gave the location. It said, hey, you're a model that was built in Abu Dhabi. And so that was leading these queries to kind of use Abu Dhabi in a different way than other cities. And it's just a reminder that you need to think about the system prompt whenever you're working with these models. And I can guarantee you, most of you have not, right? If you go look at the Claude system prompt, it'll take you like 8 or 9 minutes if you just want to read that straight through. And I'm sure very few people have done that. But those 1,700 words in the prompt can have an effect. And it could be a different effect depending on the query that you're asking that could affect that response of the model. So as you start using these models more, you need to spend time looking at those system prompts as well. So these are just some of the things just on the input side that can affect it. Now, when we get over to the model side, you got to remember these models are all very different. Even if you take two models that are very similar. So if we take a look here, and I don't think I can show it with my mouse properly. I'll hover it, but we'll see if it shows up. But take a look at two models that are very similar to each other, the Llama 70B and the Llama 3B or 8B model. Very high text similarity, but they're not perfect, even though they've probably been trained with very similar, if not exactly the same data, right? The 8B just had a little bit less of it. And so I hope this gets the red light that these models, when they give the output, just the nature of the design of them, even if they're the same family, is going to lead to different types of outputs. And this is always a consideration when you're moving from one model to another. You always have to run your evals to make sure that everything holds up. I can tell you on our team, we've seen sometimes going from 2 to 2.5, actually we can see a regression in lots of behaviors where we have to go back and change the prompts that we're using. These models have a lot of their own nuances. Some of these models, for example, can be very sycophantic. I love using that word, right? They can be overly nice. They can love you too much. We saw this when OpenAI released GPT-4.1, and then they pulled that back because it was just way over the top like that. But this is a consideration with your prompts. Besides that, when you're using commercial APIs and you don't have control of that model and the weights, well, things can change over time. They can update those models without telling you, and people have been measuring this and seen this type of drift like that. And there's lots of reasons for it, but Anthropic recently released a post where they showed that, some of the things, they had some very technical reasons for why things were going wrong, like context windows, output corruption, but these lasted for days and degraded and changed the outputs of your models. So things you need to be aware of when you do this. And I'll tell you, if you think you're just using open source and you can control it, kinda, but the VLM, the inference endpoint that you use, somebody could have updated that and changed that. So even with the weights the same, you have to think about the entire infrastructure stack when you want to make sure things are the same. And of course, there's always things like hyperparameters that you can go and modify. You can modify, right, your top P, your temperature. You can set temperature 1 for the models to be very creative. You can set it all the way down 0 because you don't want the model creative. You want it to take the biggest thing out of its probability, like that. These are all things that you can control, but they can affect the output. Now, one recent thing, and if you're not used to GPUs, this is a little bit new, is often the way we implement these LLM models, they're non-deterministic inference in practice. So with a traditional XGBoost model, I can set my seed, and then my inputs, I should always get the exact same outputs. It's deterministic. Here, even if you set the seed, even if you give the same inputs, you can have differences. And then there's a number of different reasons for this, and this is why I give lots of people. It can be the floating point error can accumulate, because often it's not just your floating point, it's combining with others that can cause slight rounding differences can do that. There's also things with mixture of experts models where you have different batches, different activations for that. And so the reality is it's very prevalent to have non-deterministic inference. around this. And if you look carefully at many of the providers, they'll have a page in there. They're saying, hey, we're not being able to guarantee determinism. Now, and this is why we always watch these videos. We've had a recent update. The folks over at Thinking Machines spent a little bit of time and figured out, hey, if you correctly batched things, you can try to defeat this non-determinism and have it deterministic. There was, I believe, a slight latency hit for this approach, but I just saw in the last week or two that it's been introduced in VLM. So there may be a chance, but you'll have to check with your folks to see if you're able to get deterministic inference with that. But for the most part, I think all of you should be aware of the non-determinism problem with GPUs. So that's it. We've covered the model. There's still one more interesting thing. Even if all those are the same, changes in the outputs can change that. And here what I like to do is go back to MMLU, because there we were trying to get a multiple choice output. And you're probably like, Raj, multiple choice output, 4 choices. How tricky could this be? Well, let me tell you. How are you going to tell your model to select a choice? Are you going to tell it, select the first letter when you think about it? Or are you going to tell it to look at the entire answer and be able to come up with a determinant? There's more than one way to kind of do this, where you can limit it to one of the existing choices. And in fact, we see this with different implementations for the MMLU, where we saw that these models were doing different ways, right? Just fix it to those 4 letters and that's it. Have it generate the text and use the first letter, compare the full answers like that. And this has a meaningful effect on the overall performance about which approach you use. And so this again shows you the value of understanding this and recognizing this. And I shared a spreadsheet, this is a little bit dated, but had a bunch of open source LLMs where they use the exact same prompt, and you can see just a humongous variety in the output of these models like that. And recently now, we don't just look at outputs. With reasoning models, they're making decisions. For example, deciding what tool to use under what conditions. And this is another area where we're going to see a lot of non-determinism, where different models at different times, you're going to pick different tools. And I've seen it internally in our own things, is sometimes it uses the tool, sometimes it doesn't. That can be a little bit tricky when you're building these workflows, as we'll talk about, like that. So I tried to shove all this stuff into one slide. Hopefully by walking through it, this is a little bit more palatable and understandable. But this is one big takeaway I want all of you to understand. If you're not familiar with everything that I talked about, these are all pieces that you should understand how these stacks work, because that way you can make sure you're going to get consistent outputs, and none of these little things are going to trick up when you're working on your applications like that. So I know it feels chaotic. I've showed you a lot of stuff, haven't made you feel better. Don't worry, we got a lot of tools up our sleeve that we're going to be able to do this. And let's walk through now. We're going to spend a big chunk of time. How do we evaluate a GenAI app? Now, as a starting point, you're going to have some type of prompt. You're asking the model to do something, like a summarization, extract a city. Then what you're going to need to do is get some labeled output. We'll call it labels, we call it output, call it a reference, call it gold, a lot of different words for this, but you need this ground truth, another word for it, to help doing that, because you use that ground truth to compare to your model output. And that tells us, are they consistent? Are they lined up? Now, ideally, if you have enough humans, you would just have humans check all of these all the time, but usually humans are too expensive and too tired to work all the time. So a common technique is we use an LLM that reads your prompt, that reads the outputs and says, are these things the same or not? As we'll talk about, this works pretty well. Now, I'm not asking for an exact lexical string match. I'm just saying, hey, do these things say the same? And you can control the prompt for the LLM judge with a little bit. So for example, these two, in this case, we're going to treat as equal. This makes it a lot easier to run your evaluation by leveraging the strength and the power of kind of an automated judge to do that. Now, if you use that equivalence that I was talking about as your metric, you can almost just treat it like traditional machine learning where you have a hyperparameter where now all you're trying to do is change the knobs in your application to maximize that equivalence. And you'll go through and you'll be like, okay, I'll change this prompt. Did my equivalence go up? Oh, I changed this model. Did my equivalence go up? That's how you can then try to help improve your model. That's it. That's a very simplified way of how to do all of this. And this is the good part. It's a lot like classic ML evaluation. Now, the bad part about this is, like you can see, like you can't stuff the entire dragon in the box because there's things we're missing here, okay? There's other aspects of the answer that we're not catching when we just focus on this equivalence thing. The other part is sometimes it's really hard to generate that gold answer. And so I want to kind of touch upon that as well. And so here what we want to do is go into a more targeted evaluation where I've shown you the stuff you can get quickly out of the box, but if we spend more time with the data, spend more time understanding, we can up the accuracy of our models. And what this involves is taking time to build tests. Now, to building tests, what we need to do is dig deeper into the problem set. So here I have an example. Look, it looks good right away, right? It's got a nice answer for that. While this response here, we're going to call the bad example. Now, I'm going to ask you, why are we calling this the bad example? What is it about it that's bad? And maybe some of you can think about it, but this is one of the biggest things I want you to learn and take away is to understand what's bad about this, to understand what's wrong with one of your evaluation sets. You need to go talk to those experts. One of the biggest problems I see, and especially I know as data scientists, AI developers, we want to go find an optimal solution. We want to just look for an archive paper. We want to look for an algorithm. We don't want to leave our chair. We just want to find an answer by ourselves. But evaluation is all about solving problems, and we need to go out and talk to others. And having this collaboration with the users, with the domain experts is a must. And this is where, if you want to succeed in this field, if you want to build successful applications that people are happy with, you got to go out there, talk to the domain experts, talk to the users, pretend you're a naive user and kind of bootstrap her up. But this is a big part of doing this. You're not going to just solve this with formulas and listening to videos like me. Because once you have this knowledge, then you can go through all those examples that we showed earlier, and you can be like, oh yeah, these things are related to each other. This is a cluster, a type of behavior we see, and the light bulbs start going off, and you start to see patterns in your data. And then when I say what that bad example is, you can be like, oh yeah, well, you know what? It's too short, right? The tone, it lacks professional. You can explicitly kind of start to tell me what's wrong. And you need this because once you have that explicit knowledge, once you know exactly why, then what we can do is start to build tests. So what I want you to do is when you have those prompts, the models has their responses, have your humans evaluate those model responses. Have them go through. Now, you're not going to do everything, but even a small subset, have them write down what they think is good about that response and what is bad. Because you can then use that to start to build tests. Now, sometimes you can do this in Excel. You can build custom evaluation tool. Don't go overboard with building custom evaluation tool, but you can make it easier to work with your experts like that. But here, for example, we talked about, oh, it's too long. Well, you know what? We can build a simple test in Python. Right? We don't need a fancy model. This is just basic Python that says, hey, is this something under 8 words or over 200? Let's flag that. I could build another test which looks at the tone and style. And here, I'm going to use an OpenAI model. I'm going to use that LLM as a judge to see what was the style and tone, because these models can effectively do that. And when I do that now, when I run my prompts through, I can look at the response that was given, and then I can have this automated test, which tells me which answers passed the length test, which ones didn't, which ones passed the tone test. like that. So now these are my new automated tests that help me figure out where my failures are. Now, as I'm working on this, one step further I can always do is as I'm building tests, we still want to use equivalence, but let's make sure that equivalence is lined up with our human evaluation. Because the whole idea of that equivalence is we just want to take the burden off our humans to check every one of these. So it might involve slightly changing the prompt, changing that equivalence judge so it aligns, right? Aligns with that human. And if they're looking at the world differently, it's not very helpful. You need them to be aligned to do that. Now, and I know that this is where we got a lot of questions at. Now, when you're doing this, one of the things to be careful about is you're using different judges for different pieces here, as we talked about. You're having that equivalence judge that we talked about. You might use other judges. These models, they love themselves. If you give a GPT-4 model text, it likes its GPT-4 text better than text from other models. So just be aware, if you're using models together that are the same, they're going to like themselves better. To get them a little more critical, you want to mix it up. You want to use Claude for one, GPT-4 for another, Gemini for another. So this is just a little trick. It's not going to make a huge difference, but it can make enough of a subtle difference that you want to think about kind of making sure you don't limit yourself to this self-evaluation bias. We talked about the alignment piece. You always want to make sure that the humans that are checking your things, and you should be having humans spot check at the beginning and all the way through, that they're lined up with what your LLM judges are doing. Now, these LLM judges, we talked about the self-evaluation bias. They have lots of other biases. So if you're somebody getting into this field, you should take a look at these biases. You should slowly learn this, because this is going to affect your evaluation results over time. If you don't, for example, know that LLMs, for example, favor the early answers over the later answers. So really you need to scramble up your answers every once in a while, or otherwise that bias is going to carry through to your evaluation like that. All right, we're making good progress here. So now that you've done this, what we can do is start to collect the results that you have and figure out what are the patterns that we're seeing. And this is error analysis. I can go through and see, oh, look, when I did GPT-4 or when I did GPT-3, how many failures did I get in tone? How many did I get with GPT-4? Right? This helps me figure out, like, oh, I can compare these two to see what's going on, right? Or I could compare two different prompts. This is the value of having all these test cases. Now I have a better understanding of where my failures are and how to fix them like that. One of the other tips you can do is when I use equivalence, I always like to ask for an explanation for equivalence. I just ask it to give me one sentence to explain its decision. That helps me a ton. Like, these models are really useful if you have them explained. It just kind of helps you focus your thinking about what are the relevant pieces of information for why it made its decision. Now, the explanations aren't exactly what the model's doing. Like, don't go too far with that. It's just a heuristic to help you understand what's going on and make quicker sense of this. So all of this is really this kind of evaluation flywheel. My buddy Hamill, he's done a course. If you find him on X or Twitter, he talks about this stuff all day long. But this is the idea for what you're going to do. You're going to go build that evaluation. You're going to analyze things. But then you're going to build these tests, see how they are, and figure out where your weaknesses are, improve it, build that evaluation, spend some time with the data. This is a flywheel cycle that you're going to continually do to do that. So let me show you one more example of how we even go crazier with this. Suppose you're building a financial analyst agent and you care about the style. And this is a real world use case. This happens all the time. People are very particular how their responses should be like that. Now, when you assess the response here, and you can see the response here, it's kind of long. It's not like a one sentence kind of thing. You could write a global LLM test that says, hey, was this explained as I would expect for like a financial analyst at a regulated firm? It's one approach you could do. What I want to introduce you to, we've talked about tests. we can build unit tests. So suppose I think of style as composed of 6 elements: the context, the clarity, precision, compliance, actionability, and risks. I can build a unit test for each one of those. And so what this allows me to do is, now when I want to check a query, I can go and just look at the results of the unit tests. And that gives me an idea of where the answer is working well and where it isn't. Versus if I just use that global test, like there's a lot of stuff for me to read through to figure out exactly like where the model is. And the great thing with the unit tests is you can even combine them, cluster them together, and find patterns in them. And I have a whole notebook and a whole worksheet kind of showing you how to do this. But hopefully the light bulbs are going off here. As you look for errors, you can group them, look for larger clusters of errors along the ways like that. All right. A little bit on unit tests, but what I want to do is keep moving on. Lots of good things you can do with unit tests. All right. So all of this so far kind of comes under the bundle of error analysis of what we want to do. Now, you guys don't get all my fun jokes. What I want you to do is make sure that when you're thinking about error analysis, you change one thing at a time. If you try to change too many things, and it's very, very tempting, right? There's like 4 or 5, right? There's so many settings. Change one thing at a time, see what the effect is. As you're going through, as I've shown you before already, we categorize the failures. We keep track of it. As you find examples that are outliers, edge cases, or really good examples, like heart them, save them, favorite them, find a way to keep track of them, because you're going to want to come back in them in a few days. And if you haven't done that, it's a pain in the butt to try to go find it. Finally, use some type of tool that gives you logs, traces, so that way you can go back and do that investigation as well. There's a ton of them, as we'll talk about on the market. Now, as you go through this, if you haven't done this stuff before, you often see people tell a story like this. Like, hey, we started off, the performance wasn't that great, but then we started tweaking some things. We're able to get to a really good performance where we did it. And this is this nice, like, linear history of the natural progression of what happens. Let me tell you, that's not actually how it happens. The reality is it's often you do a couple steps forward, you fall back, you do a couple steps forward, you fall back. Like, it's not like that. So as you're working through this, if you get frustrated at times, just keep sticking with it. It will get better. And I think that's the difference between people who've done this for a while versus new people, is people who've done this for a while know if you keep sticking with the approach that I told you, you will slowly improve the application and it will get better, even though you might not see it at your current state like that. When you're working with use cases in GenAI, an important consideration is to do user acceptance testing. And this is because, unlike traditional machine learning where you had a holdout data set that you could use to see if it generalizes, we don't really have that in GenAI. Your holdout data set is your users. You have to involve them early on because otherwise your application won't work very well. So what I tell people is build that initial evaluation data set, spend some time trying to optimize on it, but then go test it with your users. Has to be that production settings because they're going to give you invaluable feedback that you didn't catch the first time. And then you're going to use that to update your eval data set, do some more hill climbing and figure out what you improve. And then the cycle keeps going until you're happy enough where we want to go ahead and move it into production like that. Relatedly, as we get to these GenAI applications, they're big, there's a lot to it. And so one of my favorite quotes is when we're dealing with like these huge, overwhelming tasks is, how do you eat an elephant? Right? You eat it one bite at a time. Same thing for GenAI. Like the first time through, you're just basically seeing, does my app work or not? Like not trying to catch every edge case. Over time, you'll continue to add tests as you notice, oh, really, we need to focus on this point, or oh, this point is it. And so your initial app might just have a handful of tests, but 6 months later, if this app is useful, you've kept building on it, you might have 80, 90, 100 tests for that same application as well. So that's the normal flow. Don't try to do too much all at once like that. All right, we're making good progress here. Hopefully I've been going not too fast for you. Last thing I want to touch, Agentic, right? It's the way the world is going. We know, we see so many of this. And the trouble with this is the idea of the agentic is now the model's making decisions. It's using its reasoning, its tool calls to decide, should I fly? Should I swim? What other approach should I take in doing this? And this giving the model this agency makes it much harder for us to track what's going on. So here was a simple example I saw for kind of imagine a model that's going to look at the input, and then based on that input, it's going to make a decision for what the customer wants. Do they need to search for a product? Do they need customer support? Do they want to track a package? Now, once it decides which of these things the customer wants to do, this is that router function. The second step is to actually execute and do that complete workflow. So I want you to break down these tasks when you have it like this. Like, what is that initial decision that's going on around which of these workflows we're going to follow? And then we can look at the efficacy of each of those workflows and how well the model does upon that. This is the kind of breaking down that you have to do when you work with this stuff. You have to find ways to bite that elephant and make it easier. Similarly, like Snowflake has this text-to-SQL agent, seems really fancy, but again, you can kind of break this down into pieces where, for example, they have an initial piece that says, hey, is this a good question for us to take as a SQL agent? And so they have this quick classification at the front end. We can build a test, we can build and evaluate just this portion of it before we go in and look at the rest of the text-to-SQL like this. And one of the things you'll see is as you go into more of these agentic things is all of these LLM agents are doing different kinds of tasks. Here, they're finding files, finding actions, failing to use tools. We can build and test and evaluate each one of these. And it's the same process we talked about, where you're going to assess how well it's doing the routing, assess the individual age steps, see where it's working, where it isn't, categorize all of that. It's just a lot more, but it's the same kind of basic action, error analysis action. And let me tell you, I know it gets complicated, right? Like this is a huge workflow which has lots of steps to do this. And I think we're still figuring out our way for what's the best approach as you build these more complicated workflows, where you're not going to go in from the start and be able to evaluate every step of the process, where maybe you look end to end for some, maybe for some of them you actually break it down into micros. And I think we're all just learning and trying to figure out how we do all of that. As you're doing this, one caution I have for people is there's a lot of agentic frameworks out there. They're great for demos, great to kind of get you started. But a lot of times they can abstract away the technical details, which is nice, again, for a demo. But then if it breaks, if it fails on you, then it's like, like you have to end up going in, looking at the code and trying to do it. So yes, you can use them for demos, but I tell a lot of people for many times, as you move these to productions, it's best to not really rely on those agentic frameworks unless you have to do that, because it's a dependency that the world is changing so fast. I haven't seen any of them stay up in a reliable way versus just going with straight Python. It's a similar thing that we see with agentic pieces where you can build these workflows of I have certain actions that I want to do. You can orchestrate it yourself where you have control over every step like that. For some applications where you want control, you want to make sure everything works perfectly, it makes sense to do that. Now, the model providers are busy training their models to follow these types of workflows. And so they're saying, don't create these workflows, don't create these separate steps. Instead, our agents are smart enough, we'll dynamically do it. You can just trust us to do that. And my guess is for different applications, we'll do different things, but I just want you to be aware of sometimes you want to break everything down into specific pieces. Sometimes, let's just see if the LLM can handle it by itself without anything else like that. All right. Thank you all. I went through this quickly, but hopefully it gives everybody a sense of like where are the issues with GenAI that you should be thinking of. Hopefully the confidence to be like, okay, I saw how Raj did this with this application. Let me try to build my own. And this is what you should do. My own GenAI application where I build a simple evaluation data. I can test whether my model is meeting it or not like that. And just do that to give yourself the experience and the confidence to do this kind of work. All right. Thank you all.